for others who can't be part of. Okay, so let me go back into presentation mode. Okay, so I'm going to start by talking about simple threat rating and what we are recommending in terms of adjusting the simple threat rating. But then I'll also talk about the stress-based threat rating, which I'm not sure how many people use it anymore, but there probably are some teams out there that are using it. And sorry, this shouldn't say in the PowerPoint, but not presented. I am going to present that briefly. But before I go into that, I wanted to say this is really the second part of two presentations that are very closely linked. So the last webinar focused on developing what we're calling climate conceptual models to identify your climate threats. And I've incorporated just a few slides from that presentation just to sort of remind people of what we're recommending there, and also for the benefit of those who weren't able to join us last time, because it's really important to understand a little bit of this before you go into the threat rating. So let me back up. Let me back up um, and just show. I went into um, an old guidance piece that FOS produced on conceptual models many years ago to just pull out an example of how we in the past have dealt with climate change. And what we've done is we've put climate change and sometimes in parentheses exactly how it's affecting the conservation targets into a pink box, and not surprisingly it gets a very high rating. And in this case there's one stress that is also linked in here. So essentially this has proven not to be enough. We all know climate change is very complex, and it's already having and will increasingly have very significant effects on our ecosystems and species that we're trying to conserve. So the purpose of particularly this part of the climate smart open standards is to introduce a better way of addressing climate change rather than just sticking it into a threat box and calling it a very high threat. So I'm going to talk a lot about stresses. So it's probably useful to just give you a very quick review of the difference between a direct threat and a stress. So a direct threat is an action taken by a human that degrades a conservation or resource management target. It has at least one actor associated with it, so like residential development or inappropriate grazing practices, whereas stresses are altered key ecological attributes representing the biophysical impact of that action on the conservation target. And a single stress can be caused by multiple direct threats. So when you're talking about climate change, there are a lot of stresses. So rather than using the typical purple bubble that Marathi has in it um, for identifying those stresses and including them in conceptual models, what we are recommending is that Marathi has a new factor called these brown biophysical factors. And so what we're recommending when I say that you need to start by building a climate conceptual model is that you look at how climate change is going to affect your conservation target. So here, this team is working on conserving conifer forests in the western United States. And because of fire suppression, there's an increased fuel load, which is contributing to larger and more severe wildfires. And there's poor post-fire regeneration of the conifers, causing loss of forest cover, because in addition to the fire suppression, they've also got climate change. So these are the climate factors down here. So they've got increased temperature and decreased annual precipitation contributing to hotter and drier conditions. So those hotter and drier conditions combined with the increased fuel load contribute to larger and more severe wildfires. So mapping things out like this using these linkable biophysical factors, which we're using basically as stresses, allows you to then say um, which of these do you want to treat as which of these climate factors, these ones down here, do you want to treat as a direct threat so that you can rate it in the threat rating, and it then will get increased attention in the conceptual model, and so lots of reasons for including it in the threat rating. So basically, what we're recommending is that teams develop. I mean, there are different ways you can do this, but one of the best ways of doing this is that you develop a climate conceptual model. Um, and this is an example of one. It's from the Bahamas. Um, and this team is working on conservation and restoration of coral reefs. And so this is the situation without climate change. Like there are a bunch of direct threats like unsustainable coastal development and illegal and unsustainable fishing practices and water pollution that are causing a bunch of stresses, increase in macroalgae, decrease in live coral, loss of seagrass beds. And then you add climate change into that, and there are even more stresses, less habitat for sea urchins and for lobster due to decrease in structural complexity due to ocean acidification. You've also got sea level rise, increase in sea surface temperature, and an increase in storms. So lots of stuff going on. So this climate conceptual model, you'll notice it doesn't have any of the contributing factors. It's just zooming in on the conservation targets, the direct threats, the stresses, and then these additional climate stresses that, of course, interact with the direct threats and with the stresses that are caused by those direct threats. So once you've done that, then you can treat some of these stresses, like in this case, it happens to be these ones in the box here, as direct threats. So, you can rate ocean acidification, sea level rise, increase in sea surface temperature, and increase in storms. And then add those to your overall conceptual model as the most important climate factors. So this is just a typical conceptual model, not a climate specific conceptual model. So again, back here is where you really zoom in on all the complexity of climate change and how it's interacting with the direct threats and stresses and the different conservation targets. And then you just pull out the most important factors to include those in the overall conceptual model. So that very briefly is a summary of what we talked about last time in the climate conceptual models presentation. Let me stop there and just see if there are any questions. No? Okay. Feel free to take yourselves off of mute. I assume that people can, that I'll be able to hear you. Whoops, sorry. If you have any questions, because we have a fairly small group, so I'm happy to field questions as we go along. Okay, so whoops, sorry. There we go. So basically, the difference between a regular conceptual model and a climate conceptual model is, again, that it's really zooming in on these factors, the conservation target, your conventional direct threats, and the stresses that they cause, as well as these what we're calling climate threats that technically are stresses, but we're treating some of them as threats. And the purpose of the climate conceptual model is to understand the potential impacts of climate change on your conservation targets and how they may interact with your conventional direct threats. Okay, so now let's go into threat rating. So one of the things that we are recommending is that you use a slightly altered set of criteria. We've changed one of the criteria for rating threats, and also that teams consider possibly using a different time frame for rating climate threats. So for conventional direct threats, you guys know that the time frame is over the next 10 years, and the criteria are scope, severity, and irreversibility. So what we're recommending for climate threats, like sea level rise or ocean acidification, is that you either use a longer time frame, like maybe the next 50 years, or consider using two time frames, like you could use sort of a shorter term, next 10, 25 years, 25, 30 years, as well as a longer term time frame to look at, more like closer to like from the mid-century to the end of the century kinds of impacts. And in terms of the criteria, that we've found that irreversibility is always very high when you're rating direct threats. And so it's not a very useful criterion. It doesn't really help you to, it just, it makes for like all of the climate threats end up being rated as very high, essentially. So that kind of defeats the purpose of doing a threat rating. So we're recommending that teams use the criteria of scope and severity and feasibility of management, and I will define that in a few minutes. So for each threat target combination, so this is the simple threat rating. So you're just taking one of these, what typically would be called a climate stress, but treating it as a direct threat, like, changes in the precipitation regime, and rating it according to scope, severity, and feasibility of management. Feasibility of management actions that would help the target to adapt to climate change. So scope is going to be, the same. In this case, this team decided to use a slightly longer time frame, and the scope ended up very high. And actually, sorry, this team used two different time frames. So this is just the shorter term time frame of the two different time frames. They also had a longer term one. So even in the short term, the scope is very high. Scope is typically very high, but not always. So in the case of climate threats, some climate threats where the scope would not always be very high include, sea level rise will not affect all waterbird species breeding habitat or all of an island conservation target, just the shoreline. In cases where an ecosystem target is a climate refugia, so like a portion of the stream is less affected by temperature increases because there is cold water, groundwater inputs, or if part of a species target's life history is outside of the project scope, then the scope of climate change may not be very high. So very frequently, scope is going to be very high, but we just wanted to point out some cases where it wouldn't be. So severity. Severity in the case of this example where we're we're rating changes in the precipitation regime over the near term and its effects on tidal marsh. These guys rated it as medium. The threat is likely to moderately degrade or reduce the target within this time frame, the present to 2034. So that's a pretty straightforward application of severity. So severity doesn't really change a whole lot. Okay, so here's our new criterion. Challenges related to management, the feasibility of management. Basically, the degree to which the effects of a climate threat on a target can be mitigated within a given time period, near term or long term, and the feasibility of those mitigation measures. So if you guys remember, with the threat rating, very high has to be a negative. So I'm sorry if the wording here is a little bit awkward. Initially, we were just calling this, the title is still feasibility of management, but like very high feasibility of management would be a positive thing. So we had to sort of switch it around. So the very high would be very high management challenge. So very low feasibility of management. So it is very unlikely that there are management strategies that can help mitigate the climate threat within the scope and time frame, or mitigation measures to offset the climate stress have very low feasibility. It requires a significant amount of resources beyond what's currently available, requires actions by multiple partners, is politically challenging, or is technically challenging. So that's very high. Let me go on. I'll read through all of the different ratings, and then I'll stop so that I can see if you guys have some comments or questions. So high management challenge, so low feasibility of management. There's some possibility that the effects of the climate threat can be mitigated near term or long term, but mitigation measures to offset the climate stress have very low feasibility, requires a significant amount of resources, requires actions by multiple partners, is politically challenging, or is technically challenging. So medium management challenge, medium feasibility of management, there's some possibility the effects of the climate threat can be mitigated. And I guess that would be actions are feasible with a moderate commitment of resources. And then low management challenge, in other words, high feasibility of management. It's likely that there are management strategies that can effectively mitigate the climate threat within a given time frame, near term, long term, and it would take a relatively small investment of resources. So I'll just jump here to this next slide that shows an application of this. So this approach was developed by the Fish and Wildlife Service in California. They're a team of folks who work on fish and wildlife refuges. Developed this criterion and have used it, and John and I sort of adjusted their wording a little bit, but we thought that it would be a good substitute for irreversibility. So let me stop there for a second and see if there are any questions or comments from you guys. What do you think about this new criterion?
I think it's great, Marcia.
Thank you, John. So others, what do you guys have any thoughts about our, replacing irreversibility? Does this seem like a feasible approach to getting around the fact that irreversibility is not too helpful?
This is Sean Finn. I'll throw in that obviously it's a kind of a different approach, and it's a new and perplexing challenge that we're all facing. But I think that throwing something down like this and testing how well it works within the OS environment, this is a really good approach here. The one thing I often think about for climate change, and I know that this is dealt with in other parts of the open standards, but is the uncertainty. And I think for me anyway, there's multiple levels of uncertainty when you're dealing with mitigation or adaptation to climate change. So all kinds of things that go from very biophysical things like, what's the level of greenhouse gases, all the way up to social and political response to it. So at this point, I like what I'm seeing, and I definitely am interested in sort of exploring how effective it could be in the open standards process. But I'm always going to be thinking about the multiple complexities of uncertainty that climate change presents to conservation and conservation delivery.
Thanks. That's a very good point. And the reason that we're proposing using scenario planning is really to try to manage or at least understand the uncertainty. But you're right, the uncertainty is sort of at multiple levels with climate change. And yes, a big factor is also how are people going to react, and so that's a very good point. Um, Thoughts from anyone else?
This is Jody from the Nature Conservancy. I just had a question about the criteria. So when you say feasibility of management, I'm just curious, feasibility for whom? Like, is it a general feasibility, or does it mean feasibility for the organization or the team that you're planning with? I'm just wondering if you could clarify that. Thanks.
Yeah, we mean feasibility for the team that is managing this, but really asking, like, is there something that could be done? I think that although we have within here, the amount of resources as sort of a part of it, of course, whether or not you have those resources is going to be different if you're a large agency versus if you're a small NGO. I think the more important part of this is really to get at, is there something that can be done, or is this just a, a problem where you can't really do anything?
Okay, I think that helps. And then I had a separate question too, but along these lines. So I think that sometimes I've been experimenting with treating climate stresses like threats for a while, and I find that in a lot of our planning situations, what we see is that climate changes are amplifying stresses that also have direct human causes. And so when I think about evaluating those, in terms of feasibility, there may be sort of a climate-induced part of that change that we can't control. We can't control the air temperature or something, but we can control some of the other human-caused direct that amplify that cause that same stress. And so I'm sort of trying to think about, with these criteria, how you sort of sort that out. Does that make sense?
Yeah, that completely makes sense. And that's actually something that I'm going to talk about in the second presentation that's a part of
Okay.
this session, when we get to strategies, because basically John and I are recommending thinking about three different categories, three different broad categories of climate smart strategies. And each of those broad categories then splits into a couple of, they have a couple of sub strategies under each one of them. But the first one is threat abatement, because of the fact that there are those interactions between climate and the conventional threats on the same stresses very, very often. So, if an area is getting drier and people are pumping water to use it for irrigation, well, you can't change the fact that the area is getting drier, but you can change the amount of water that farmers take out of the streams for their irrigation, and promote drip irrigation, or something like that to address that direct threat, because you're right, there very often are those interactions.
Okay. Yeah, that's exactly the type of example I was thinking. Thanks.
This is Elizabeth, and I am new to this group, so forgive me if my idea isn't relevant. But I have a database of the Northeast State Wildlife Action Plans that includes 14 states from Virginia to Maine, and includes all the climate change threats. And I checked to see what how that had fallen out in terms of reversibility, because I hadn't really thought about it before you mentioned that everything is irreversible. And we have more than half of the climate change threats are ranked as irreversible, but there's still a fair number that states ranked as reversible. And they are mainly things like storms and flooding and habitat shifting, which I guess they're thinking, so a lot of hydrologic things that are probably more like changes in the precipitation regime, that don't necessarily, it's not like sea level rise where once it goes under, it's under, but right. These are more like things that have shifting frequency, but not necessarily like a permanent change state. So I just wanted to mention that, and I'll put the link to our database in the chat window, and anybody's welcome to use the Northeast State Wildlife Action Plan database, and you can explore them for yourself.
Great, thank you. That sounds like a great resource. Yeah, I can see how things like changes in precipitation patterns can go in one direction and then can go in the opposite direction. It can get drier, and then it can get wetter a few years later, and so people wouldn't really classify that change as necessarily irreversible.
Or they might be assuming that they can compensate for the change by like creating similar habitat, just shifting it uphill, or they might be assuming that they can, because they're only really thinking about it from a wildlife standpoint. It's always the target.
Yep.
Which sounds like feasibility of management, I think.
Yeah.
Yeah, it is. Yeah, it totally overlaps with that. Yeah.
Yep.
So it makes sense what you guys, how you shifted that focus.
Okay, so any other comments? If not, I will just keep going here. So basically, once you've done a threat rating for, oops, sorry, this keeps getting out of presentation mode. There we go. Once you've done a threat rating of both the conventional threats as well as the climate threats, you'd end up with something that looks sort of like this. So this is an example from the San Francisco Bay, U.S. Fish and Wildlife Service complex of wildlife refuges. And you can see that for each one of the direct threats, they rated the direct threat in the near term as well as in the long term, and not surprisingly got higher ratings over the longer term than the near term. But the whole idea here is to show how the climate threats are interacting with conventional threats, and to have those threat ratings on there. Okay, so that's all I'm going to say. Oh, actually, sorry, one more slide. But I don't have much more to say about simple threat rating. Then I'm going to talk about stress-based threat rating briefly. But just a few examples of climate stresses that we're recommending to treat as direct threats and to rate as direct threats, like sea level rise as it affects tidal wetlands, change in precipitation regime as it affects vernal pool ecosystems, increasing temperature as it affects the reproductive success of sea turtles, drought affecting forests, increased temperature affecting brook trout, change in precipitation, particularly decrease in snowpack and freeze thaw, increase in ice affecting caribou. So, okay, so now let's talk about the stress-based threat rating. So again, we are recommending change in the time frame and change in the criteria. So for those of you who haven't used the stress-based threat rating, it's a little bit different. There are 4 criteria instead of 3. So there's scope. You rate the stress in terms of scope and severity, and then you rate the threat in terms of its contribution to the stress and again, feasibility of management instead of irreversibility. So let me show this in a different way here. So you have a conservation target that's affected by a stress, and that stress is being driven by what the Nature Conservancy used to call sources of stress, which we call direct threats. So first you rate the effect of the stress on the conservation target in terms of scope and severity. And then you rate the contribution of this direct threat and the feasibility of management of this direct threat in terms of its effect on the stress. So let's just look at an example of that. So tidal marshes, the stress we're going to look at is change in plant composition, and the climate threat is changes in the precipitation regime. So first we're going to rate the change in plant composition in terms of its scope and severity. And then the to what extent changes in the precipitation regime contributes to changes in plant composition, and feasibility of management of these changes in precipitation regime. So in terms of scope, there are significant changes in the plant composition that are projected within the chosen time frame, which the team has to decide. Are you going to use a longer term time frame like 30 years or 50 years, or are you going to rate this over the near term as well as over the longer term, as that other team did that I showed you? So that got a very high. And sorry, we don't need that slide because I'm assuming that you guys already know the open standards. So severity, again, severity is the same as always. So the level of damage giving continuation of current circumstances and trends. So within the scope, the stress is likely to moderately degrade or reduce the target. So again, rating the plant composition. And so then you rate the effect of the threats on the stresses. So in this case, I find it helpful to rate the different direct threats that are all affecting that same stress at the same time, to look at, okay, there are changes in plant composition that are happening and are projected to continue happening due to changes in water temperature due to climate change, changes in the precipitation regime due to climate change, as well as invasive plants. And then say, what is the expected contribution of each one of those different sources? And you can see that, in this case, the invasive plants are contributing more than either of the climate direct threats. And then, oops, why does this say irreversibility? Okay, so typically this would be irreversibility, but in this case we're recommending using the feasibility of management instead. So in this case, because we're talking about changes in the precipitation regime that's driving changes in plant composition, the team rated this as having very high. I'm sorry, I didn't adjust the wording of these slides because I didn't use these during the CCNet rally. So they rated this as very low management feasibility. So very high management challenge, I think was what we were calling that. So same concept, just applied to the stress-based threat rating. So that's it for this presentation. I wanted to keep this presentation relatively short. Oops, and we've actually used almost half of the time. If Are there any other questions, or should I just jump to the other presentation, which is on strategies? Okay, I'm going to take that as a yes, you can jump to the other presentation on climate smart strategies. Okay, so this presentation is on brainstorming and prioritizing climate smart strategies. And John and I believe that while it is important to use your conceptual model, of course, to understand the potential impacts of climate change and interactions with conventional threats, that it's also useful to consider different categories of climate smart strategies, just as you're thinking about what you can do. And we're calling those three categories: conventional threat abatement, viability enhancement, and this last one we're calling strictly adaptation, and I'll explain what we mean by that. Um, and and then, we do want to develop some climate criteria to incorporate into the rating of strategies, but we haven't really gotten to that yet. So what I'm going to be presenting right now is our categories for climate smart strategies to keep in mind. So let's say that you are working in an area where you're trying to conserve mountain meadows, in part because they're important for water supply, especially in the dry season, um, for towns and agriculture. So those mountain meadows are affected by altered hydrology, in part due to increased snow melt due to climate change, and in part due to diversion of water for municipal use. So there are different types of actions that you can take to address this. So you can promote water conservation. So that would be a typical like threat abatement strategy. So this is an example of, I think it was Jody who mentioned, where you've got a conventional direct threat interacting on the same stress with a climate threat. So by reducing this threat, you can then hopefully help to mitigate the impact on that stress. So that's one category. Another category is viability enhancement. So you could restore the mountain meadows to improve water supply and water quality. And then the third category, and we actually have two examples, we have sort of our two subcategories on this slide as well, are what we're calling strictly adaptation. So one of those subcategories is strategies to create artificial habitats or conditions for natural systems to adapt. So you could store water in tanks to ensure ecological flows during the dry season. And also adaptation strategies, but to prevent human maladaptation. So you could capture and store rainwater in the lower watershed for human use during the dry season, so that people aren't taking a whole lot of the water up in the mountains that's needed for the biodiversity in the mountain meadows and in the streams. Okay, so let me go into more details on each of these categories, and then I will open this up for questions. So within that category of conventional threat abatement, we have a couple of subcategories. One is strategies to reduce a climate-related stress by reducing a conventional threat. And the other is strategies to protect climate refugia, so occurrences of the target not exposed to climate change. And I have examples for uh, all these different subcategories. So let me just run through what our categories are. So within viability enhancement, we have a couple of subcategories. One is strategies to maintain or enhance viability for adaptive capacity of a target. So for example, connectivity. And the other is restoration strategies. And then under the strictly adaptation strategies, we've got the artificial habitats or conditions, as well as preventing human maladaptation. Okay, so let's look at each one of those. So our category 1A, strategies to reduce climate-related stresses by reducing a conventional threat. So here's an example of that. You're trying to conserve riparian habitats, and they're affected by altered hydrology, changes in the water level and hydro period, and changes in the flood occurrence, frequency, intensity, and area flooded. Because you've got dams and water diversions, and you've got hydropower uh, operations. At the same time, because of climate change, you've got changes in precipitation that are also altering the hydrology. You can't do anything about this, the changes in precipitation, but you can have some strategies to address the conventional direct threat, such as conducting timed releases during low flow periods. So another example of this same category is for the tidal marshes, uh, the native plant composition and the invertebrate population are affected both by invasive species as well as by a series of climate threats, changes in ocean chemistry, changes in water temperature, changes in precipitation. So again, you can't really do anything about these climate changes, but you can manage the invasive species and try to avoid other introductions of invasive species. Okay, so that's it for that category. Our next category is protecting climate refugia. So climate refugia are defined as habitats that components of biodiversity retreat to, persist in, and can potentially expand from under changing environmental conditions. So they are characterized by their ability to provide long-term, over several generations, mitigation of environmental change that makes surrounding areas unsuitable. So for example, because of climate change, you've got increased water temperature affecting the rivers and streams, and the water temperature is also increasing because people have cleared the riparian vegetation. So if you identify and protect the stretches of river that serve as climate refugia, that could be one example. Here's a diagram that has a bunch of examples of climate refugia. So like cold water inputs produce local cold water refuges in which the stream temperature is decoupled from the air temperature. Um, poleward facing slopes are less susceptible to increases in temperature. Valleys that harbor cold air pools, canopy cover, can buffer local temperature maximums and minimums throughout the year, as our previous example showed. Areas near or in large, deep lakes or oceans will warm more slowly due to high heat capacity of water. So just a few examples of climate refugia. So the idea here is to we put this in the threat abatement category because really what you're trying to do is to identify and protect these refugia. So protect them from conventional direct threats. Okay, so moving into viability enhancement. So first of all, a few words about viability and climate resilience. So increasing the viability of a conservation target will, in many cases, increase its adaptive capacity or resilience to climate change. So John and I had a long discussion about adaptive capacity and resilience and like what's the difference between those terms. And we found it a little bit hard to separate them when you look at the definitions of them. Adaptive capacity being a measure of the ability of a system or species to adjust to climate change impacts with minimal disruption, and resilience being the capacity of social, economic, and environmental systems to cope with a hazardous event or trend or disturbance. I guess the difference is here. This um, this one, they in the definition they explicitly include social and economic, but you could include that in the definition of adaptive capacity as well. Anyway, so we found these definitions to be a lot. There's a lot of overlap, but the major point we wanted to make is that by increasing the viability, you can increase the ability of the ecosystems and species and increase their adaptive capacity or increase their resilience. So some of the actions that enhance viability and adaptive capacity of ecosystems include things like maintaining or enhancing ecosystem patch size, because larger patches are more likely to be more heterogeneous, maintaining or restoring connectivity between ecosystem patches, maintaining or enhancing the dispersive capacity of ecosystems so that they are able to migrate in response to climate change, and maintaining functional ecosystems, even if those ecosystems change identity over time, and you lose particular species or the range of particular species shifts. Um, so a few examples of this are, I think we have two examples of this. The first one is tidal marshes, where you've got sea level rise affecting the extent of high quality tidal marsh. Um, so the strategy would be to protect land to allow inland migration of tidal marsh as sea level rises. You know, if people build their houses just inland of the tidal marsh, then the tidal marsh is not going to be able to move inland as the sea level rises. So, so preventing development in those areas is important for maintaining and or enhancing the target's viability and adaptive capacity. I guess we just had one example of that one. Okay, so our next subcategory is restoration. So in this case, our example is the team's working to conserve riparian habitat, which is affected by changes in water level and hydroperiod and changes in flood occurrence, frequency, intensity, and area flooded because of changes in precipitation. And so one possible climate smart strategy would be to restore the riparian areas with species that are more drought tolerant. And another example of this is the example that I mentioned earlier, restoring mountain meadows to improve water supply and water quality. Okay, so our final category of strictly adaptation strategies and our two subcategories. So creating artificial habitats or conditions for biodiversity. The idea here is to create artificial habitats or conditions that will support biodiversity and or the provision of ecosystem services under expected climate change. So if you are working to conserve coral reefs, both because of their biodiversity value as well as the fact that they produce a lot of fish that are important for fisheries-based livelihoods in coastal communities, and those coral reefs are are increasingly affected by coral bleaching due in part to climate change, then installing artificial reefs could be an example of what we're calling a purely adaptation strategy. So a few examples that we brainstormed of this, creation of artificial habitats or conditions include using beach umbrellas to shade nesting habitat for sea turtles, using dredge material or other materials to create artificial nesting habitat for coastal water birds, creating artificial wetlands, installing artificial reefs to increase fish biomass, as I mentioned in that previous example, which also can provide coastal breakwaters, or creating artificial oyster beds to enhance habitat for fish, shrimp, crabs, and improving water quality. When I was looking at this earlier today, I realized this kind of actually bleeds into restoration. So there's maybe this example fits under restoration rather than the artificial habitat category. But anyway, our last category here is preventing human maladaptation. So maladaptation is defined as an adaptation that does not succeed in reducing vulnerability, but increases it instead. So it includes actions that, relative to alternatives, exacerbate stresses on ecosystems and species. It includes taking actions that later prove to be ineffective under the new climate conditions, or actions that push the problem downstream, like engineered solutions to flooding that exacerbate stormwater runoff in a different area. So one example of maladaptation is as sea level rises, people have a tendency to want to put in seawalls in order to protect their real estate. And of course, that from the perspective of the mangroves is a maladaptation strategy because it just squeezes the mangroves, decreases the area where they can live, and thus the mangroves are not able to contribute to protecting the coast. So it's maladaptive, not just for the mangroves, but also for coastal communities. So that's this example in the form of a conceptual model. So if you want to protect communities from storm surge and help them to be resilient to natural disasters, then installing seawalls would be a maladaptive strategy. And a better alternative would be protecting upland areas and facilitating inland migration of the mangroves so that the mangroves can help to protect the coastal communities. And of course, there are other strategies like, keeping people from developing so close to the coast. So just a few examples of strategies that are maladaptive and some better alternatives. So if you're working to conserve rivers and streams, and an associated human well-being target is agriculture and the need to supply water for agriculture, and you've got a climate stress that's drought. So a strategy that is maladaptive would be to intensify groundwater pumping or surface water extraction. And a better alternative to that would be water-saving irrigation systems or planting drought-tolerant crop varieties. Another example, if you're working to conserve estuaries, which are also contribute to protecting coastal communities, you've got sea level rise and storm surge. This is the example that I showed in the previous slide. Shoreline hardening is a maladaptive strategy. Better alternatives include vegetative plantings and construction regulations, setbacks, so that people don't build right along the coastline. And the final example, if you're working to conserve rivers and streams and wetlands, which contribute to protecting urban communities from natural disasters. And your climate stress is flooding of rivers during extreme rain events. Building dams would be maladaptive, but restoring wetlands and riparian habitat would be a better alternative. I've also read a little bit about reintroduction of beavers in areas so that they can build their beaver dams and keep more water further up in the watershed, thus contributing to reducing flooding in a more ecological way. So that's it for this presentation. What I can do is go back to the slide that has our, here we go, our categories, and see if you all have questions. Sorry, I know that was a lot in a hurry, but are there questions? Are there comments? Any thoughts about our different categories of climate smart strategies?
Maybe they're just anxious to watch the England-Croatia game.
Yeah. Well, if there aren't any comments or questions,
Marcia,
yes.
Nico here. I do have actually two questions.
Yes.
If there's not anybody else. One is looking at the categories.
Hmm.
I don't know why, it might only happen in my head, but I somehow associate climate refugia with the viability of an ecosystem somehow. So a bit like you would associate the connectivity of an ecosystem with viability. It would also make sense for me to place that category under the viability enhancement strategies and less in the threat abatement one. So that would be one question. If you could repeat the reasoning why it ended up in the first category. And
Yeah.
yeah, okay, answer that first. Yes.
Yeah, let me answer that one first. So we originally had it under viability enhancement. We moved it because we felt that the action that you would take in most cases would be to identify and protect the climate refugia. So you're trying to essentially prevent conventional direct threats from degrading that climate refugia. But
Okay, but
It would change if you were actually restoring a refugia. You'd put it under viability enhancement.
yeah,
But because you're trying to protect that refugia from threats, that's why we put it there.
would that also imply that the refugia would become a target then?
It would just be a habitat for a species, for example. I mean, or an example of an ecosystem that wasn't likely to be as affected by climate. Just like we don't typically make corridors a target or a specific protected area a target. It probably wouldn't be, but it would be the subject of a lot of effort.
Yeah, okay. I think both somewhat make sense because obviously the climate refugia, if you compare it with the connectivity discussion, like you wouldn't put corridors down as a target, right? It would be part of the viability of your ecosystem you are looking for. And the same might apply for climate refugia. And then there are different conventional threats coming in that alter the viability of this target you are dealing with. So yeah, somehow the reasoning works in both directions, but I understand what you mean. It also makes sense the way you put it.
yeah, I think you're right. It could fit under the viability enhancement. You know, in some cases, you might find that there aren't really a lot of direct threats. Like if you have, say, you have a stream and you have some cold water, groundwater inputs coming into that stream, there there may not really be a lot of threats that would, prohibit that from acting as a refugia. It's more that you need to need to identify those climate refugia and think about those climate refugia as you're planning, as you're thinking about the viability of your conservation targets.
Yeah. Yeah.
So I could see arguments for either category.
Yeah, makes sense. And my second question would be if you could go back to these examples for maladaptive strategies, to that slide where you have the different examples.
Like this one?
No, the table with
Oh,
different one.
that one.
Yeah, this one, the first one. The first one, I think the logic you have built up here makes full sense. However, you could also, I think, turn it around and say agriculture is actually a threat to the rivers and streams instead of a human well-being target.
Yeah.
And then your strategies would actually be your better alternatives in the last column would probably be threat abatement strategies, right? So just as a heads up, basically, depending on how you put it, it could be a good alternative for adaptation, or it would be a normal threat abatement strategy. Did you run into these issues oftentimes, and are there, let's say, rules to the game how you would differentiate the two?
Yeah, that's a good question. I think that comes down to the definition. It comes down to what your project is focusing on, the definition of not just your conservation targets, but also your human well-being targets. I mean, is this a project that is focusing on both conserving ecosystems and species and maintaining livelihoods so that the ability of people to continue doing agriculture in the area is an important part of what you're trying to achieve? Or is this more of a like straight conservation project where you may want to think about other strategies for working with the farmers to restore those areas and take them out of agricultural production? As you say, I think it would be more site specific, I think.
Yeah, I think it's a scope question, and another example of why we like to separate conservation targets and human well-being targets and not mush them all together so that we can understand, agriculture can be helpful for humans, but it can also be a threat to the conservation targets.
Yeah.
Yeah. Yeah, and in building guidance for ecosystem-based adaptation and conservation, we're going to have to make sure that those things don't get mushed, because in the ecosystem-based adaptation case, your focus would be on the agricultural, the human well-being side, and you're asking, what can you do to maintain or restore ecosystems in order to continue to have those ecosystem services. Anyway, I just noticed Elizabeth sent me a message saying that she can't seem to open the files on the Google Drive. She can navigate to them, but they won't open. Has anybody else had that problem? I know I've asked people to test those, the recordings, and people have told me that they worked for them. I'm happy to try to troubleshoot with you, Elizabeth. But please people should let me know if they also have problems with that.
It is working for me. I just tested it.
Good. great. I mean, I think I put the settings at like, you know, anybody with the link can open it and watch it, and so it should work. But Google Drive can be funky sometimes. Any other questions? I was expecting this presentation to take more time, but the previous one actually took more time. So we got through this one relatively quickly, but I hope I didn't go too quickly. No? Okay. So I guess, really these categories are, the intention of developing these categories is just to help people to think about climate smart strategies and different types of climate smart strategies to keep in mind. Climate change is really overwhelming, and it's easy to just feel like, oh my God, this is too much. We're going to lose so many of our ecosystems and species. And so these categories are just to help people to think about what we all can be doing to help our ecosystems and species to have greater adaptive capacity and resilience in the face of climate change. So comments are welcome as if you use these materials. Please let us know if we can be of help, and let us know if you have feedback for us. So thanks, everybody.
Thank you, Marcia.